Once again, welcome my dear students. Now in the second lesson, data representation. In this lesson, I am going to discuss the four different types of numbers: binary, decimal, octal and hexadecimal. Why these number systems are important to us, all these things we will discuss in this lesson. Now in this chapter, we will discuss the conversions and we will discuss all the different numbers can be converted in all the different types of number forms. Means every number can be converted in every other numbers. So this all the different conversions one by one we will discuss. Now in this digital techniques, nowadays we are using everything, and in this we have to save the data. For that purpose we have developed four different types of number systems. Computer can only understand binary number system, but rest of the other number systems are used to store the data in a compact form. Basically, hexadecimal can't be understood by the machine directly. Decimal number system can't be understood by the machine directly, but these number systems are very much helpful in compressing the data, and the large data whatever we have, that will be compressed in a small form. Now in this regard, first is our digital number system. So everything we have the data in our computer system, whether it is song, text, movies or any other type of file, that will be in digital form in a computer system, and whatever we will save, that will be converted in the binary format, means 0 and 1. Then computer can understand that binary format. Now in this regard, first is our decimal number system. Decimal number system. Decimal number system. Now what is decimal number system? And I will discuss one by one every number systems in detail, and then after we will start conversion with different forms. Now first thing, what is decimal number system? Decimal number system is represented with the 10 digits 0 to 9. Means digits, if I am talking about digits, then 0, 1, 2, like this it will go 9, means total it will be 10 digits. In this 10 digits, the number of digits is called base, means how many digits are there. Here we can see 10 digits, so its base is 10, means the decimal number system is having the base 10. Now in this number system, every digit is having its positional value. We will consider these digits according to their positional value. For example, 3479, we have this number. So in decimal number system, decimal should be there. If I am talking about decimal, so where is the decimal? At the last, means if there is no decimal, then at the end of the place there will be a decimal, and after this decimal, zeros are there. These zeros are not having any value this time, so we can erase these zeros. If we will write any number 3479.15, like this if we are writing, then these numbers will have some certain values, and then after this number will have a place value also. This is the first number. Whatever the number will be in the left hand side, this is called MSB. What is the meaning of MSB? Most significant bit. And the number, this is called LSB. Right hand side, this is called least significant bit. Why this is so? Because of this place values. This is called units place or ones, tens, 100, thousands. This is ones, tens, hundreds and thousands place. This is the place value. According to this, if we are having more digits, then we can 10,000, then lakh, then 10 lakh, like this it will go. So in this number system, every number will have its position, and with that positions we will define the positional value of that number. This is having the least value, means this is 3000, this is 400, this is 70, and this is only 9. That's why it is called LSB, least significant bit, and this is called MSB, most significant bit. Now in this regard, if we have the decimal values, so I have already discussed decimal will be here. Now we will increase the place value from this side to this side, and we will increase the place value if any decimal number is there from this side to this side. If we have, for example, 265, so we will increase the place value from this side, and we will increase the place value from this side. This is our point. Now we will read it like 3479. We will not read it 265. We will read it as 3479. This is a decimal. 265. We will read it 265. If we have any other 2, 3, 4, 5 numbers, then we will read it one by one. We will not give any kind of place value like 1000 or any other thing. We will directly read the number one by one. This is the main concept here. Now in this, how it will be understood? This is our ones, tens, hundreds, thousands. This is, and in this we will add th. This is called tenth. This is ones, so this is tenth, we will add th, tenth. This is called hundredth. This is called thousandth. This is called thousandth. This is called hundredth. This is called tenth. This is called ones, tens, hundreds, thousands. So like this it will go. This will go that side, this will go this side, this will be increasing that side, this will increasing this side. So like this we will segregate this number system. Now then after, I hope this is clear to you. Every number system is having a place value. So how we will read this? How we will if we are using in conversion, then what power we will give to this? So if this is, then according to the place value I am writing 3 into 10 to the power, this is at the fourth position. So we will start from 0, 0, 1, 2, 3, so power 3 plus 4 into 10 to the power 2 plus this is 7 into 10 to the power 1 plus 9 into 10 to the power 0. This is our dot. Now then after, this number 2 into 10 to the power minus 1 plus 6 into 10 to the power minus 2 and plus 5 into 10 to the power minus 3. Like this it will increase. You can see this. This is just before the decimal. So we will start it from 0, 9 into 10 to the power 0, this is second, 7 into 10 to the power 1, 4, 4 into 10 to the power 2 and 3 into 10 to the power 3. So you will count the number and you will start from the one less number. Then after 2 into 10 to the power minus 1 you will write here, 6 into 10 to the power minus 2 and 5 into 10 to the power minus 3 you will write. You will not write 0 again after decimal. So this is the way by which we will evaluate this number. I hope this is clear to you, and this will be helpful while we will convert one number system to another number system. Next is our binary number system. What do you mean by binary number system? Binary number system is having only two digits, 0 and 1. Only two digits are there, 0 and 1. If only two digits are there, then its base is 2. Now in this number system, we will use the base 2 while conversion, while evaluating. So in this binary number system also there is a place value, and that place value or the digits, whatever the numbers we have. For example, one number I am taking 1010.0101. If this I am taking, very similar to the decimal number format, as it is, we will increase this side and that side. We will write this one, first count the number 1 2 3 4 4 it is, so we will start it from 3. So 1 into 2, we will take the base of this binary number. Base of this binary number is 2, so 2 into 10 to the power 3 plus 0, 0 into 2 to the power 2, this 0, then plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. This 1 into 2 to the power 3. Why we have taken 10 in decimal number system? Because in decimal number system base is 10, and in binary number system we will use 2 because its base is 2. This 0 into 2 to the power 2, 1 into 2 to the power 1, 0 into 2 to the power 0, plus, very similar to decimal number system, 0 into 2 to the power minus 1. As we will proceed that side of decimal number system, we will use the inverse of that, minus 1, plus this 1 I am writing here, 1 into 2 to the power minus 2 plus 0 into 2 to the power minus 3 plus 1 into 2 to the power minus 4. This 0 I have written, sorry, this 0 I have written here, and this 1 I have written here. So you can see in this clearly that as we will move after the decimal, this decimal, so 0 into 2 to the power minus 1, 1 into 2 to the power minus 2, 0 into 2 to the power minus 3, and 1 into 2 to the power minus 4. This side we will start from 0, that side we will not start from 0, we will start from minus 1. So this is the basic concept while solving these numbers. If we are having only the first part, we are not having any binary number system after the decimal, so no need to evaluate all these. We will discuss only this if we are not having this form. So this is the binary number system. Now the third is our octal number system. In octal number system, digits are 0, 1, 2, like this 7. Means more than 7 this number system is not having, so we will not use 8, 9, 10 in this octal number system. We will use only 0 to 7, and in this case how many digits are there? 0 to 7, when you will count 8 digits you will get, so its base is 8. Its base is 8. Now while conversion we will use this 8. These are the numbers, this may be the number given to you, but this base is important in this octal number system. Now one example I am taking. In this example 3721.2406, like this example I am solving first without this decimal so that it will be more clear to you. Now in this, if we have to evaluate this octal number, first you have to check in octal number system more than 7 should not be there. If 8 is also present, then this is not the octal number system, be confirmed. This may be any other thing, hexadecimal or decimal it may be, but if we are using 8, 9, 10, 11, 12, whatever the number more than 7, then it is not octal number system. So this is given to you. Now this is octal number system because maximum number is 7 and our digits in octal number system is 0 to 7 only, so it should come in between that range. Now in this I have to write, first you have to count the digits 1, 2, 3, 4. If 4 it is, then you have to start it from 3. Now 3 into 8 to the power 3. Why I am writing this 8? 8 I have written because this octal number system is having the base 8 plus 7 into 8 to the power 2 plus 2 into 8 to the power 1 plus 1 into 8 to the power 0. This is the representation. Now if with this number system, if some decimal values are also present, for example 2406, so 2406, again I am showing you, complete number is here 3721.2406. Now how will you represent, how will you evaluate this octal number system? First main thing you have to check, no digit should be more than 7. 1 is 7 here maximum, but 8 should not be present, 8, 9, 10 should not be there. So in this maximum is 7, 0 to 7, it is clear that it is octal number system. Now I am writing this 3 into 8 to the power 1, 2, 3, 4 it is, so we will start from 3 plus 7 into 8 to the power 2 plus 2 into 8 to the power 1 plus 1 into 8 to the power 0 and plus 2 into 8 to the power minus 1 plus 4 into 8 to the power minus 2 plus 0 into 8 to the power minus 3 plus 6 into 8 to the power minus 4. So this is very much similar as our decimal and our binary number system. You can see it clearly. Now in this I am marking this line to make it more clear to you. This is the first part of the octal number system. In this 3 into 8 to the power 3, this 7 into 8 to the power 2, 2 into 8 to the power 1 and this 1 into 8 to the power 0. Now after this decimal we will start from minus 1. This already we are doing this practice, and many other terms also I have shown you. 2 into 8 to the power minus 1, 4 into 8 to the power minus 2, 0 into 8 to the power minus 3 and 6 into 8 to the power minus 4. Like this we will evaluate this octal number system. So you must remember the number of digits present in it, and the number of digits is the base of that number. Like in decimal 0 to 9, how many digits are there? 10 digits, so its base is 10. In binary 0 and 1, So how many digits are there? 2. So its base is 2. In octal 0 to 7, how many digits are there? 8. So its base is 8. So that's why we are using this 8. So in decimal I will use 10 here, in binary I will use 2 here, in octal I will use 8 here, and in hexadecimal I will use 16 here because 16 digits are there. Now the hexadecimal number system. In hexadecimal number system there are 16 digits. These are digits 0, 1, 2, 3 up to 9. It will be very simple. Now if I have to write 10, then it will be represented as A, 11 will be represented as B, 12 will be represented as C, 13 will be represented as D, 14 will be represented as E, and 15 will be represented as F. So these are the representations. So 9, this is 10, 11, 12, 13, 14, 15. So total 0 to 15, this is 16. So that's why this number system is having the base 16. So this is the base of this number. Now why we are representing the 10, 11, 12, 13 as A, B, C, D, this must be clear to you. One number I am taking, one, 1, 2, 7, 5, 1, 4, 1, 2, if this is a type of number. So if I am reading this 11, this is 12, then this will be your certain code system, this will be certain code system. Here also this is the confusion. Now if I am writing only this, then again this will create confusion. So whether these two are combined, this is not clear, or whether this middle term is combined, this is not clear. So there may be several forms to understand these kind of numbers. So this should be clear that this is 11, 12, or this is 1, 11, 2. This should be clear. So how this will be clear? This will be clear only with the help of the code system. We will give certain values to the numbers, and then we will read the number according to that code system. Now in hexadecimal number system also the variation will be the same, as we will use any number like 3, 5, A, 3, point B, C. If this is the number in hexadecimal number system, if we have to evaluate the number system, the process will be similar as we have already solved with the 3 different number systems already. This 3 into 16 to the power, you have to count it, 1, 2, 3, 4 it is, so you will write 3, plus 5 into 16 to the power 2, plus A into 16 to the power 1, plus 3 into 16 to the power 0, plus I have written this 5 here, I have written this A here, I have written this 3 here. Now for this B into 16 to the power minus 1, plus C into 16 to the power minus 2. Now few students may think that how we will evaluate this A, how we will evaluate this B, how we will evaluate this C. So you have to follow that code system as already I have given. We will represent 10 as A, 11 as B, and 12 as C, 13 as D, 14 as E, and 15 as F. So this is the representation of the binary number system. So while evaluating this number system, you will use that code. You will evaluate 3 into 16 to the power 3, 5 into 16 to the power 2, plus what is the value of A. This is having the value, and this is only for representing the value here. So we will not be worried about this A. We will use the value of A 10 into 16 to the power 1 plus 3 into 16 to the power 0 plus what is the meaning of B? B is 11 into 16 to the power minus 1 plus what is the value of C? 12 into 16 to the power minus 2. So we will replace the code with the number, and then after we will evaluate it. So this is very simple, and the process of evaluating all these number systems are similar with all the 4 number systems. This is the common thing. And we remember one thing, that computer will understand only binary number system, because this is tough to work with the different level of voltage. Means what is 0 and 1? This is 0 means off, 1 means on. So this is very easy to understand by the computer also, that off and on, electricity is there or electricity is not there. But if we will use the 9 voltage levels in like from 0 to 9, if we are using 10 voltage levels in decimal number format, so this will be tough to understand by the computer system, and it will be tough to maintain that voltage level. Means 10 means high voltage, 9 means slightly low, 8 means slightly low, then again 7, then how it will be managed by the computer system, that low, high, there are certain limits. But in the binary number system, 2 only. If yes, 1, electricity is there. If 0, then electricity is not there. That's why we are preferring binary number system. And the other number systems we are working with to store the data in our computer system. While understanding in computers, every number system, means decimal, octal and hexadecimal number system, will be converted in binary only, then computer will understand. And our data may be stored or represented in hexadecimal or octal number system in the computer system to save the memory, to save the data. Now this was the number system, and in our next video, in our next class, I will discuss with you the conversion. Now this is my humble request to you all, my dear students. As you will mention the topic in your copy, means decimal number system, then the concept which I have written on the board you will write, like then binary, then octal, then hexadecimal. As I have written the concept on the board, you will write in your copy, maintain the notes. When I will start the conversion, at that time it will be very helpful to you to understand it. Now thank you for today. Thank you. Take care.